Section 3.6 is kind of an interesting section. It's a good recap on the first half of Chapter 3, but there's not a whole lot more that we learn in Chapter in 3.6 that you don't currently know. We'll talk a little bit about limits. This is technically 3.5, limits at infinity, but we're going to skip through it a little bit. So some of the rules are as follows. Now, first off, always watch to make sure that you're going to positive infinity versus negative infinity when you do these problems. Most of the time it doesn't make a difference, but some of the times it actually does. So if we're going to infinity, or generally negative infinity, we look at the powers, especially for polynomials. And if the power on the top is lower than the power on the bottom, so if you're bottom heavy, you're going to be taking a big number and dividing it by an even bigger number. So we're dividing by something really, really large, which you're cutting your pizza into an infinite number of slices, which really just means you end up with 0 pizza per slice, if you think of it that way. So if it's bottom heavy, you go to 0. Now, you got to think of the overall degree. So the square root of x squared, that's really kind of x. Now I know it's x minus 9, and that minus 9 is a little bit weird, and this does not reduce down to x minus 3. It's just not. So the top power is just x. So we have a 1 exponent on the top and we have a 1 exponent on the bottom. So if they're the same, you generally get just the ratio of coefficients, which is 1 over 2. So this will be half. And I would like it to be the same in both directions. And it is here, but in this version it's not. And it's easy to tell if you look at the graph of these that you go to half on the right side, but not half on the left. So this actually ends up being a negative 1/2. And let's think about why that is. So on the bottom, if you plug in negative infinity, you're going to get a negative 2 times something times infinity, basically. So if you pull that negative out, you'll get a negative 2 infinity. On the top, well, you're squaring a negative infinity, and you're squaring a negative number makes it a positive number. So this is a positive up top. You square root it, it's still going to be a positive. So this numerator is always going to be positive. And as you go to the bottom, you get a negative. So positive or negative is a negative. That doesn't happen here because they're both positive, both numerator and denominator. So you got to be really, really careful to make sure that you're just watching that. It happens with the square roots more than anything else. So, general rules so far. Bottom heavy goes to 0. Even powers, you get the ratio. But you really got to be careful if you're plugging in negative infinity. Sometimes their negatives are going to cancel out, and sometimes they won't. Alright, so in this example, we have top heavy. So if something is top heavy, then it just goes to infinity. Another way of doing this, and it doesn't matter if you go, well, is it true both top and bottom, both left and right? Let's take a look. So on this side, you have a positive infinity divided by a positive infinity. Well, what happens over here? Well, if I plug in negative infinity, I'm going to get a positive over negative. So that'll actually be negative infinity. And if you think about like division, this will end up being basically a linear equation, but this part right here won't be. So you'll end up getting like a slant asymptote. And on the left side it goes down forever, and on the right side it goes up forever. So you can always verify these with a graph. So finishing up here, we'll go up to example 1, which I kind of skipped over. That was an accident, it wasn't really on purpose. But that's okay. So the rules again, if they are the same top heavy, bottom heavy, the rules are the same, so it's just 2/3. Now, do we have to worry about the negatives? Well, let's see here. If you plug in a negative, you're going to end up with a negative infinity over a negative infinity. 2 negatives will cancel out, and you'll just get the 2/3. Okay, so for this problem, in the whole section, you're basically trying to get a graph of some sort of function without using your calculator. Now, I would really suggest that at some point along this process in this section, you just type your equation in your calculator and make sure that you're not going off on some wild tangent here. So the way you do this is you try to just bring in everything that you know about math, period, and put it together. So it's nothing new, it's just kind of using your knowledge in a slightly different way. So we take the derivative and the second derivative of our function, and you will have to do this on your own sometimes, but just for speed's sake, there they are. And we're also going to find everything we know from like AAT. We're going to find our horizontal asymptotes. Well, that's the limit as x goes to infinity. So we are evenly powered, so our horizontal asymptote is going to be at y equals 2. Okay. Vertical asymptote, that's anything that makes the denominator equal to 0. So we have x minus 2 and x plus 2 for the bottom. So we're going to have two vertical asymptotes. So x equals plus or not. X equals plus or minus 2. Okay. Alright, so what's our x-intercept? X-intercept is where y equals 0. So when you do this, you really have to worry about where the function equals 0. Where the denominator is equal to 0, that's your vertical asymptotes and possibly holes. Where the numerator is equal to 0, that's where the whole function equals 0. So we're going to have x-intercept at x equals 0. So we'll cross the x-axis. And technically be 0, 0. Now have a y-intercept, if you plug in 0 for x, you get 0 again. So we're going to cross at 0, 0, basically. So our x and y-intercept are the same. Alright, so critical numbers. We look at our first derivative, find our critical numbers. And we have 0 from the numerator, and sort of plus and minus 2. Now they're not exactly critical numbers, but they are what makes the derivative undefined. They're not critical numbers because they're not numbers in the function. But when we try to find out if they're maxes or mins, you still have to make them on your chart. So below on the screen here, where you can't see, but you can see on your pages, there's an f prime of x chart. And I'm going to do that right here. And I'll do the f double prime in a second. So when you make this chart, you still are going to put your -2, your 0, and your 2. They're not critical numbers, but they go on the chart. Okay, so how do we tell our signs? Well, the bottom is always positive because of the squared, and the numerator will be positive when x is negative. So these will be positive when we're left of 0. If x is positive, then this makes this negative, and negative over positive would be a negative. So it doesn't change signs, it's increasing through there, so you're going to have vertical asymptotes increasing and then increasing. That's really what that means. You know it's a vertical asymptote here, and you know here that it's increasing, and it's increasing. If you know about vertical asymptotes, they all have this kind of shape. Sometimes they go this way, which would be increasing and then decreasing, but it kind of has to look like this. But we'll get to that in a little bit. So it's increasing, and then it starts decreasing, so that means we have a max at 0. You won't have any other relative maxes or mins. This is the only one we've got. It's a relative max because it increases, it decreases, and it's there. Alright, points of inflection. That's where our second derivative changes signs. So we've got this equation that we have to solve, and, well, we know that we've got positive 2 and negative 2 on my graph. So negative 2 and positive 2 definitely go on there. But the question is there any way that this numerator could be equal to 0? And, well, the easiest way of doing that would be to graph it really and just see, does it cross 0? And the annoying part about that is, yeah, it requires us to kind of use a graphing calculator. You could use a quadratic formula on this if you really wanted to by hand. And I don't remember off the top of my head, but I don't think this crosses again. So let's bust out our calculator and just take a look at it real quick. So I'm really worried about, does the numerator, and that's really all I'm going to do. So I'm not going to cheat too much. Does this cross 0? So 3x to the 4th minus 8x squared minus, oh, I'm not looking up, 3x to the 4th minus 8x squared minus 16. Okay, I'm going to graph that. Alright, well, it crosses twice that we can see, but what are you going to bet that those are positive 2 and negative 2? So you really, as long as it actually hits 2 and goes 2, 0, yeah, so we've got positive 2 and negative 2. You could use those to factor this out, and now I'm thinking about it, this is probably a factorable equation. I could take out a couple of these, make things a little bit simpler, but I don't see any other crosses. We could try and zoom our window out, but we're not going to get any more information from this right now. Alright, so our points of inflection are negative 2 and positive 2, so what changes signs? Well, we can cheat a little bit on this and look at the graph and see what happens, or we can always just plug things in here. So let's plug a number in the middle, 0. So the bottom will be positive, because it's even. And then if we plug out the 0 on the top, we're going to get 0, we'll get 0, you get negative 16 times positive 16 makes it negative. Okay, so if we plug in something like 3, if you remember the graph, it went like this, right? So if I plug in 3, here's 2, 3 will be positive, so this thing will be positive if I plug in 3, or negative 3 because it's above the x-axis. So these are both positive. The bottom I don't have to worry about. I don't have to worry about the 16. I just have to worry about the numerator. It says positive or negative. Between these 2 points, it was negative. Outside of the points, it was positive. Alright, so the culmination of all this is we've got to try to make a graph without looking at the calculator too much. I know we cheated a little bit by just trying to find out where that crosses 0. Okay, so I'm going to just use this space right here to make my graph. So the first thing I would do, put in our horizontal asymptote and our vertical asymptotes. That's what I would put in first. That's the bones of our graph. So we have 2 vertical asymptotes at 2 and at negative 2. We have horizontal asymptote y equals 2. So again, this is not really part of the graph, but these are the bones of the graph. Now, to tell you the truth, you probably could just go off the first derivative. You don't really need to go off the second derivative. And make sure you label these charts if you make them. So first derivative chart and second derivative chart. Other things to kind of keep in mind, we have a maximum at 0, but we know it's 0, 0. Okay, so we get a maximum there. But think about this. This is the maximum. It has to go here. Now, the graph could do something weird where it bounces back up, but we know that there's no other place where we have no other critical points. So it can't turn. It has to be a maximum, and it has to approach these lines. So it's generally going to look like this. It kind of has to. Now the question is, outside here, are we down here? Are we up here? Are we over here? Are we down here? And we can either use our concavity. It has to be concave up. You can't really be down here and be concave up. It just doesn't work. So it has to be over here to be concave up. Also has to be increasing. It can't be in here and increasing. The only way it can be in this little quadrant would be decreasing. So I'm increasing and concave up. That means my graph has to look like this. Over here I'm concave up, and I'm also decreasing. So concave up, can't be down here and concave up, and I'm decreasing. This is what this equation looks like. If you want to be more precise, you feel free to plot more points. You can go x, y, and just start tossing in all sorts of numbers if you want. Negative 5, 7, doesn't really matter. This will give you the overall shape of the graph, and everything else is just details. So it's nothing really new in this section, but you got to practice being able to go from one to the other.